Oh, hi there. Thanks so much for showing up for your math learning. It's Mr. Jennings, and we are starting a new unit, and it is exponential equations. And we're also going to be looking at the inverse of exponentials in this unit, which are logarithms. So that's going to introduce a whole new chapter to your algebraic development. Today is mostly review of previous topics. So without further ado, let's keep going. So we want to really make sure that you have your laws of exponents drilled, you know how to do that, and that you can also use that to create equivalent exponential expressions and use the change of base method to solve exponential equations. Logarithms gives you a robust algebraic way to change the base. So in order to do that in any situation, we want to do it in the specific situations where we can finesse things. So our laws of exponents, we have, if you have the product of powers, we add the exponents. We have divide the powers, you subtract the exponents. Note, this is commutative. You can do a to the x times a to the y is the same thing as a to the y times a to the x, but this is not commutative. Addition doesn't matter the order, subtraction does. Division matters the order as well, multiplication doesn't. Okay. This is commutative as well because it results in multiply the powers. So that is to say a to the x to the y is the same thing as a to the y to the x. And that's actually a useful manipulation that you can use sometimes because in any case you just end up multiplying the powers and that doesn't matter what order you do it in. Okay. If you have something that is itself a product and you raise it to a power, you can bust it apart that way. For example, if I have 6 to the 3, we know that's 216, but it's the same thing as 2 times 3 to the 3, which is to say this is 8, 2 to the 3, times 27, 3 to the 3. All of that will give you 216. Just manipulate, and different forms of it are useful for different reasons. Same thing with fractions. If you have a division and you raise that to a power, then it's the whole thing. The numerator and the denominator all raised to that power. And anything to a zero exponent equals 1, not 0. Okay, so there's lots of practice in working with exponents in the worksheet and on delta math. So dive in, get that practice going. All right, now, negative exponents, I call this the bossy landlord. So if we have a to the negative n, the negative just says, hey, a, take all your stuff and move downstairs. So a's stuff is the exponent, and it just, if it used to be upstairs, it now goes downstairs. And it moves, otherwise nothing else changes. Okay. You can also just know that this is the reciprocal of this. So if you have 2/5 and a negative 6, that would be the same thing as 5 to the 6 over 2 to the 6. Okay, so there's another example of the same. Okay. All right. Finally, just to review, we have rational exponents. There is a worksheet for you to practice if you struggle with rational exponents. We have if you have x to some fraction, well, the denominator of that fraction is like the index number of the radical that you would be raising that to. And then this one just works as a typical exponent of that thing. So let's say we had something like 8 to the 4/3. We could say that's the same thing as the third root of 8, all raised to the power 4. And that's something we can evaluate because the third root of 8 is 2. 2 times 2 times 2 is 8. And then we raise that to the power 4, and that is the same thing as saying 16. That's how these do. Okay? So you want to be able to go from this form to that form, evaluate without a calculator. Not be surprised if you're using your calculator to evaluate. Let's keep going. Okay, so in trick that we use to solve exponential equations is that we want to get the base to be the same, and then we can equate the exponents. Okay, so if we can equate the exponents, we can just like bring this down to another line. So that involves rewriting exponential terms with the same base. So let's take a look at some examples. So if we have over here 4 to the minus 2x times 4 to the x is equal to 64. Well, I can rewrite this whole thing as a single exponential equation. This is 4 to the minus 2x plus x. And then I can rewrite this as being 4 to the 3. Would you look at that? Oh my goodness. And then I can just like do this on both sides. I can have this is 4 to the negative 2x plus x. Well, that's just minus x is equal to 4 to the 3. Oh, well, that tells me that minus x equals 3 and x equals minus 3. And that's true. Okay. Next, over here, this one's a little trickier because I got 81 multiplying 9, and then that's equal to 27. So there's a couple ways I could do this, and I'll show you both. First way is just to, whenever you see that, just like, oh, I'm multiplying by something, I'm going to divide by it. So I'm going to divide both sides by 81, so I'd end up with 9 to the minus 2b minus 2 is equal to 27 over 81. 27 over 81 is just 1/3. All right, and then 9 could be written as 3 to the power 2. So that's 3 squared, all raised to the minus 2b minus 2. And 1/3 could be written as 3 to the negative 1. And then this here, I can multiply the exponents. So 3 to the minus 4b minus 4. Don't forget to distribute. Okay. And then I can equate the exponents because I now have them both as terms of 3. So this is minus 4b minus 4 equals minus 1. Kick everything to one side, and you have b is equal to minus 3/4. Is that correct? It's correct. Yeah. Okay. What's the other way, you ask? Well, the other way is to rewrite the whole darn thing in terms of powers of 3. So 81 is 3 to the 4. 9 to the minus 2b minus 2 is 3 squared to the minus 2b minus 2 equals 3 cubed. And I've got it all in terms of the same base. I just apply my power laws at this point. So here I am multiplying powers. Got to do this first. Got to multiply first before you add these exponents. So that gives me 3 to the 4 multiplied by 3 to the minus 4b minus 4 equals 3 to the 3. Adding the exponents here gives you 3 to the minus 4b equals 3 cubed. And then we equate our exponents. Minus 4b equals 3. That is to say that equals that. And b equals negative 3/4. Oh, would you look at that? We got the same thing doing it 2 different ways. It's almost like that's really a useful way to check your work. Okay. Wait a minute. What? How are we supposed to write 1 as a power of 4? Well, that's the easiest question we've seen yet. This is 4 to the 0. And this is 4 to the 2x plus 3. So that is to say 2x plus 3 equals 0. And x equals minus 3/2. Solve them. Pause me. Oh, you're back? Okay, so you really wanted to see me do these together, eh? Okay, sure, fine. So this is add the exponents 6 to the minus 3x. This is 6 to the minus 3. This is a fancy way of saying 6 to the minus 3. So then we equate the exponents. Minus 3x equals minus 3, and x equals 1. That's it. I'm not really other ways to do that. Okay, this one over here, looking red for a change. Looks like we're going to be working in powers of 3. It's good to have like a number of these memorized. Okay, so 81 is 3 to the 4, and we're raising that to the 3n plus 2 all over. This is 3 to the 5 raised to the minus n, and that's all equal to 3 to the 4. Okay, well, simplify this side. Gives us 3 to the 12n minus 8 plus 8, because that's positive clearly up there, all over 3 to the minus 5n is equal to 3 to the 4, okay? And here we subtract the exponents. Just get stubborn, okay? So look at it this way. It's like 3 to the 12n plus 8 minus 5 equals 3 to the 4. And this is a little gnarly, but we're going to move that up over there. So we have 3 to the 12n plus 13. It's positive because minus a negative is positive, is equal to 3 to the 4. And now we're ready to equate our exponents. 12n plus 13 equals 4. Subtract 13 from both sides gives you 12n equals minus 9, and n equals minus 3/4. Because minus 9 over 12 is minus 3/4. Go practice and get yourselves into some kind of algebraic quandary. Challenge yourself and do not panic. Know that if you find a problem you can't answer, that's where you're supposed to be. And then you either figure it out yourself and pat yourself on the back, or you ask AI for help and upgrade your skills, or you ask me for help and I help you upgrade your skills. In any case, the goal of practice is to test yourself so that you're ready for assessments, and upgrade your skills so that you're ready for assessments and ready for the next step in your math learning. Bye for now, everyone.